On June 19, 2011, a small Swedish salvage company was towing sonar equipment across the Gulf of Bothnia when it captured an image on the seafloor that the crew would spend the next 14 years trying to understand. The object measured roughly 60 meters from side to side. It rested 87 meters beneath the surface. Behind it, a trench stretched approximately 300 meters across the seabed in an almost perfectly straight line. Each time the team moved closer, their navigation equipment stopped working. A year later, when divers finally managed to reach the site, the material beneath their hands seemed unlike anything expected from the known geological history of the region. For more than a decade, specialists who reviewed the evidence repeatedly arrived at the same uncomfortable point. First came silence, then hesitation, then a careful unwillingness to attach the object to any explanation comfortably supported by conventional Earth science. 14 years of competing hypotheses have gradually pushed some of the researchers who remained closest to the mystery toward an interpretation almost nobody wanted to consider. They have begun describing it as the corpse of technology. And once the meaning behind that phrase becomes clear, it becomes easier to understand why. Some of the people who have spent the longest studying the Baltic anomaly now seem among the least willing to speak about it. The image on the screen. Peter Lindberg and Dennis Osberg had already spent close to 10 years surveying the central Baltic with sonar before they encountered the anomaly. Their company, Ocean Explorer, earned a modest income locating shipwrecks in waters that rank among the richest archaeological zones in the world. Between Sweden and Finland, the Baltic seabed holds wreckage produced by more than 400 years of naval battles, commercial shipping storms, and maritime accidents. On an ordinary survey, a strong, clean sonar return often meant another wooden wreck and potentially another payday. But the return that appeared on Lindbergh's display that afternoon did not resemble a ship. It was circular. Its diameter was about 60 meters, and its boundaries looked unusually sharp. These were not the broken, softened outlines expected from something that had spent centuries being worn down by the sea. The edges appeared sharp in a geometric way. Some of the lines looked almost intentional. Lindbergh made another pass using a different sonar frequency. The same shape appeared again. He changed the depth of the towed sonar unit and crossed the area for a third time. The result did not change. The instrument was not malfunctioning. It was repeatedly mapping the same enormous object on the Baltic floor, an object that did not seem as though it belonged there. Osberg later explained in interviews that this was the point when the expedition stopped feeling like a conventional treasure hunt. The team had entered territory they did not yet know how to describe. Across the object's upper surface were dark areas resembling scorch marks. Their distribution did not look like the random biological buildup normally seen on wreckage that has remained underwater for a long period. Around the perimeter, several features appeared strikingly geometric. Lindbergh would later describe them during the press conference that followed as looking almost engineered. Inside the cabin, the crew passed the sonar images from person to person. Nobody gave a confident identification. Nobody could even suggest a theory that comfortably matched what was on the page. But during those first hours, the circular object itself was not the detail that disturbed them most. That was the feature behind it. A long furrow crossed the seabed in a straight line, aimed directly toward the anomaly as though someone had drawn an arrow to it. The trench extended for nearly 300 meters. Its sides looked clean and deep. Displaced material had been pushed into ridges along both edges. That was not the appearance of something gradually shaped by normal processes on the Baltic seabed. It looked more like the mark left when a massive object traveled rapidly across the bottom and then came to an abrupt stop. The scar that would not heal. The Gulf of Bothnia is relatively stable from a sedimentary perspective, but its seabed is never completely static. Currents slowly move the upper layers of material. Over decades, sediment shifts. Over a century or two, anchors, fishing equipment, cargo, and pieces of wreckage can gradually disappear beneath newer deposits. The seafloor in this part of the Baltic does not keep crisp surface features forever. Sharp forms become rounded. Edges soften. Given enough time, many of them disappear. Several months after the original discovery, Lindbergh and Osberg returned to the coordinates carrying higher resolution surveying equipment. The trench had not disappeared. Its edges remained sharply defined. It was still deep. Material displaced from the furrow remained piled neatly along both banks, and where the trench terminated against the object, there was a noticeable accumulation of debris that appeared to have been pushed forward. In the improved survey data, the trench looked almost as though it had been cut into the seabed sometime during the previous year. Yet sediment patterns surrounding the site appeared to indicate that the area had remained undisturbed for an extremely long period. That contradiction was one of the details that drew Volker Brüchert of Stockholm University into the investigation. Brüchert is a marine geochemist whose professional work has focused extensively on sediments covering the Baltic Sea floor. After examining the sonar information, his initial assessment in interviews was straightforward. The Gulf of Bothnia lies above the Fennoscandian Shield, among the oldest and most tectonically stable pieces of continental crust on the planet. That portion of the seabed contains no active fault system. There is no submarine volcanic activity beneath it, and there is no obvious geological process capable of producing an isolated mass, 60 meters, across, pulling it sideways over the seabed in one straight direction and leaving behind a fresh-looking trench roughly 3 football fields in length. Brüchert also considered whether the structure could be related to material deposited during the last ice age. But glacial movement does not normally create such a pattern. Ice produces broad zones of irregular scraping and chaotic abrasion. Debris may generally align with the direction in which the glacier traveled, but the resulting landscape is disorderly. It does not usually resemble one narrow linear groove that ends directly against a single discrete object. According to that reasoning, the sonar image was not showing an ordinary glacial deposit. It looked more like an interloper. Something foreign appeared to have been placed there through a process that the surrounding geological environment could not explain. And if the trench had been exposed to Baltic sedimentation and erosion for centuries or longer without becoming buried, then the object at its endpoint seemed to possess properties capable of resisting processes that normally reshape the seafloor over immense spans of time. That would already have made the site extraordinary. Then the expedition encountered something even harder to explain. The dead zone. During the summer of 2012, Ocean Explorer again traveled to the anomaly, this time with more advanced equipment. The expedition carried improved sonar, upgraded cameras, satellite communication systems, and additional technical specialists. Their objective was to complete the detailed investigation that had not been possible during the first expedition. While the vessel remained a safe distance away, everything worked. Satellite phones maintained their connections. Navigation instruments tracked normally. Diagnostics across the electronic equipment reported no problems. Then the vessel moved to within roughly 200 meters of the object's center. According to accounts the team later gave in several interviews, multiple systems failed almost simultaneously. Satellite phones dropped their signals. Navigation equipment stopped functioning. Sonar displays dissolved into white noise. It was as though someone somewhere below the water had flipped a switch and shut down the vessel's electronic systems at the same instant. Lindbergh ordered a complete diagnostic check. Crew members restarted equipment, disconnected, and replaced cables, performed cold reboots, and inspected the malfunctioning devices for physical damage. Nothing fixed the problem, yet the systems themselves did not appear broken. Something simply seemed to be preventing them from functioning. The crew then tried something basic. They turned the vessel around and moved back beyond the approximate 200-meter boundary. Within seconds, the electronics returned. The team repeated the approach throughout the remaining survey period. Again and again, entering roughly the same radius caused the equipment to fail. Retreating beyond it restored normal operation. There appeared to be no gradual transition. The effect behaved almost like an on-off switch. Inside the perimeter, the systems died. Outside it, they worked. The crew started calling the area the dead zone. Brüchert has pointed out that geology offers no known equivalent for an electromagnetic disturbance with these particular characteristics. Rocks rich in iron can shift compass readings slightly. Deposits containing magnetic minerals can interfere with sensitive instruments strongly enough to be measured. But neither normally shuts down a wide range of electronics across a radius of approximately 200 meters. Interference on that scale would seem to demand an active source of energy rather than a passive mass of magnetic material. Long before finding the anomaly, Ocean Explorer had spent years surveying iron-rich wrecks and known magnetic disturbances throughout the Baltic. The team had cross-charted naval magnetic anomalies without losing even a basic radio connection. Whatever effects surrounded this object appeared to operate on a completely different level from anything documented in the geology of the area. The anomaly did not seem to be merely lying inactive on the bottom. Anything aimed toward it from within that perimeter effectively became blind. That left the crew with the one approach they had hoped to avoid. If electronic instruments could no longer inspect the object from close range, people would have to descend and examine it directly. Descent into the dark. At a depth of 87 meters in the northern Baltic, the water temperature remains only slightly above 4 degrees Celsius. At that temperature, working without hand protection becomes impossible after only minutes. Under pressure and stress, a diver's reaction speed can also begin to deteriorate. At 87 meters, natural light is gone. Most visible sunlight has already been absorbed far above that depth. The problem becomes worse because fine particles remain suspended throughout the Baltics. Deep water. Instead of cutting cleanly through the darkness, a flashlight strikes those particles and creates a pale, cloudy beam that may reveal almost nothing beyond the diver's immediate surroundings. Stefan Høgeborn, ocean explorer's lead diver and a commercial diver with substantial experience in cold water, was the first to descend. He used a trimix breathing mixture prepared for approximately 9 atmospheres of pressure. Every inhalation moved harshly through the regulator. With each exhalation, bubbles rose into the darkness overhead and vanished. At that depth, and with that gas mixture, useful time on the bottom is counted in minutes. Returning to the surface requires hours of decompression procedures. Before putting the divers directly onto the object, the crew sent a remotely operated vehicle ahead of them. The ROV was equipped with powerful floodlights. In normal deep-water environments, those lights could illuminate 10 meters or more. That day on the Baltic seabed, their effective range collapsed to less than a meter. The suspended material was so thick that almost nothing recognizable appeared on the video feed reaching the ship. In the control room, the crew watched the vehicle inch through total darkness, almost one frame at a time. Then the character of the bottom began to change. The familiar soft sediment covering much of the deep Baltic gave way to a hard surface. As the camera approached, the material did not fit comfortably into the usual categories operators had learned to recognize during years of underwater surveying. It was rough and heavily pitted, yet strangely solid. It did not resemble loose weathered stone, nor did it have the smoother accreted appearance of metal that had remained submerged for a long period. The ROV extended its mechanical arm and clamped onto a protruding section. Pressure sensors recorded a hardness far above what would normally be expected from ordinary sedimentary rock. Nothing gave way. The surface did not peel off. It did not break apart. It did not crumble beneath the mechanical force. Across parts of the object were darkened, almost black areas. Very fine cracks crossed those patches in patterns comparable to the crazing ceramic specialists see when material has been exposed to kiln temperatures well above ordinary operating ranges. Other portions appeared as though the surface had once become liquid melting and then freezing solid during one sudden event. At minimum, the ROV established one thing beyond the earlier sonar interpretation. A genuine massive physical structure was lying there, but the machine could not reveal enough of it. To understand its shape, the divers themselves would have to enter the darkness. The geometry that broke them. Høgeborn went down, expecting to encounter a strange geological formation. By then, he had years of professional diving experience behind him. He had worked around underwater volcanic features, mineral deposits at depth, heavily encrusted wrecks, and biological structures capable of resembling unusual geology. He was familiar with things that looked strange. He still had categories in which to place them. When his flashlight finally reached the object's surface, what appeared in the beam did not fit any of those categories. Høgeborn has recounted the experience in several interviews. His light moved across a thin coating of sediment. Then it stopped against what appeared to be a wall. The surface rose vertically from the base. To Høgeborn's eye, the angle appeared to be an exact 90 degrees. Its scale and smoothness resembled construction rather than a randomly fractured rock face. For several seconds, he simply floated there without moving. Then he continued. Following the first wall brought him to a second vertical plane. The two surfaces met at a clean right angle. The next plane ended against another. Høgeborn slowly swam through areas he later compared to narrow corridors where parallel surfaces joined one another at precise 90-degree intersections. He placed his gloved hand directly against the junctions. What he could not feel was the smoothing expected from long-term erosion. Underwater currents gradually wear away exposed angular edges over geological time. That process is remarkably consistent. Marine geology has no recognized environment in which sharp corners and exposed stone remain perfectly angular for thousands of years, while the seabed around them continues to shift, erode, and change. Yet, Høgeborg's glove was passing across sharp right angles in a surface that felt to him like stone that had been burned. One particular feature from his dive report would become among the most frequently discussed details in footage from Ocean Explorer's second descent. Near what Høgeborg believed was the upper central region of the structure, his light caught something unusual enough that he stopped and photographed it repeatedly. There was a perfectly circular opening. Around that circle was a raised square border. The round feature appeared positioned with mechanical accuracy in the center of the square. Its diameter was approximately 1 meter. The layout resembled the kind of reinforced hatch arrangement produced through industrial fabrication. Natural geology does create geometric patterns. Crystallization, for example, can form extremely regular structures. But those patterns appear on the scale of individual crystals, not as architectural shapes a meter wide. Erosion can carve curves, broken surfaces, and irregular angles. It does not normally form a large circle aligned precisely inside a square frame, surrounded by intersecting right-angled planes. Nothing in mainstream geological catalogs offered an obvious natural process capable of producing what Høgeborg believed he was seeing. Through his gloves, the surface felt like burned rock. Through his mask, the structure looked engineered. Those two observations had no comfortable place together. Høgeborg could not reconcile them underwater, and the rest of the expedition could not reconcile them when he reached the surface and described the dive. If you had been in Høgeborg's position running your hand across those sharp underwater angles, would you still have believed you were looking at a natural rock formation? Share your theory below and subscribe as we follow what the physical samples revealed next. The impossible material. Fragments were taken from the walls and from the region around the circular feature. The samples were brought back to the surface and eventually delivered to Brüchert's laboratory at Stockholm University. There was a relatively simple expectation behind the analysis. Once the material had been identified, geology would provide an ordinary explanation for the anomaly. The more extraordinary interpretations inspired by poor underwater visibility and confusing dive. Footage could then be dismissed as visual misinterpretation. Instead, laboratory testing identified the material as basalt. Basalt is an igneous rock. It forms when molten volcanic material cools and becomes solid. Brüchert repeated the analysis using a separate method. The identification did not change. That created another problem. The Baltic rests on the Fennoscandian Shield. The last major volcanic activity affecting this region occurred more than 1 billion years ago. No recent volcanic source exists within hundreds of kilometers of the anomaly. There is no known magma chamber beneath the site capable of generating the material where it was found. There is no thermal vent. In terms of the surrounding crust's known geological history, basalt should not be sitting there. From a geological perspective, discovering it at this location would be comparable to discovering an iceberg permanently frozen in the middle of the Sahara. There was no conventional mechanism in current Earth science that comfortably explained how it belonged there. Under electron microscopy, the material presented another strange feature. Its crystalline structure appeared to preserve signs of tremendous heating, followed by extremely rapid cooling. The crystals were unusually fine, suggesting molten material had been cooled so suddenly that they never had enough time to grow to ordinary dimensions. The thermal shock signature was compatible with something heated to temperatures measured in thousands of degrees Celsius, and then quenched in cold water over a very short interval. Materials scientists encounter comparable signatures in furnace-quenched materials and in surfaces subjected to the extreme thermal conditions associated with atmospheric re-entry. Brüchert considered whether a meteorite strike could explain it. A body arriving at extremely high velocity might theoretically produce enormous heat and potentially generate basalt-like material during an impact. But that explanation immediately collided with the geometric structures documented by the divers. Meteorites traveling at hypersonic speed do not arrive gently enough to preserve organized internal features. They break apart. They melt. they combine with surrounding material into irregular glassy impact deposits. The geological record of well-studied impact locations repeatedly shows the same basic outcome. Structure is destroyed rather than preserved. No documented meteorite impact has left behind organized square passages, standing vertical walls, and round openings surrounded by square frames. Against the dive footage, the meteorite explanation could not account for everything at once. The investigation had reached a dead end created by two sets of evidence that seemed incompatible with conventional categories. The material resembled scorched volcanic basalt and carried evidence of extreme heat. The form contained right angles, corridor-like spaces, and framed openings, suggestive of designed construction. Known natural processes do not simultaneously melt stone at extreme temperatures and arrange the result into large-scale precision geometry. Modern science has no easy classification for something that appears geological and architectural at the same time, shaped by furnace-level temperatures, while somehow retaining a structured framework beneath a burned exterior. One conventional explanation after another had failed. The remaining interpretation was the one almost nobody wanted to say aloud: the corpse of technology. Among the researchers who continued following the anomaly most closely, a more disturbing interpretation gradually emerged. The evidence, according to this view, was pointing towards something that nobody had originally wanted to name. The Baltic anomaly was not simply a strange rock, it was the corpse of technology. The idea works like this: what rests on the seabed is the surviving structural framework of something that was once artificial and functional. It was manufactured. It was engineered, and at some point far in the past, it was exposed to a catastrophic energy event, so extreme that present-day physics offers no simple framework for describing exactly what happened. Whatever substances originally formed, the structure, metal alloys, composites, synthetic materials, or something else, they were supposedly subjected to temperatures powerful enough to merge them with sediment from the surrounding seabed. The original materials ceased to exist in their previous form. At the molecular level, they were transformed. What remained was mineral. Under this interpretation, the scorched basalt identified in the Stockholm laboratory is not ordinary basalt, created through the area's normal geological history. Instead, it would be the mineral residue of material that had never originally been stone. Extreme heat converted technology into geology. The transformation was so intense and complete that the object's original geometry became trapped inside a mineral shell. The analogy is similar to fossilization. The original living material disappears, but mineral replacement preserves its form long after the tissue itself has vanished. The right-angle surfaces Högborn touch the corridors he moved through, and the circular opening surrounded by its square border would therefore represent pieces of the object's surviving internal structure. They would be the remaining framework of whatever the construction originally was, still faintly detectable beneath a burned and mineralized outer layer that once belonged to a functioning machine. The original body disappeared, its design remained. Whatever destroyed the object may also have preserved its shape at the same instant. The proposed energy event would have been strong enough to liquefy the exterior, strong enough to weld some of that material to the seabed, strong enough for rapid contact with cold water to freeze the resulting material into the thermal shock crystal pattern later visible beneath an electron microscope. Yet, beneath that destruction, the basic arrangement somehow remained recognizable. Right angles continued to intersect with other right angles. Circular features remained positioned within square borders. And behind everything, a straight trench still stretched for approximately 300 meters, appearing almost like the last surviving trace of the object's final movement before it stopped. What could have created such an event remains unknown. Possibilities discussed within this speculative framework range from something thermonuclear to a plasma-based event, or perhaps a process for which humanity does not yet possess the necessary scientific model. Whatever occurred, the interpretation does not place it in the recent past. The thermal shock structure of the material, combined with sediment patterns Brüchert documented around the anomaly, implies that sufficient time has passed for the surrounding seabed to develop characteristics associated with long-term stability. The object appears to have occupied the same location for a very long time, and that possibility leads to an even larger implication. What it means. The most disturbing implication of the Baltic Sea anomaly may not be the object itself. one unexplained structure can always be isolated as an exception. It can remain a singular mystery without forcing anyone to reconsider a wider picture. The situation becomes more uncomfortable only when the corpse of technology interpretation is compared with the broader collection of unusual formations that have been recorded across the world's seabeds. Earth's oceans remain the least thoroughly surveyed environment on the planet. Less than 1/4 of the global seafloor has been mapped at high resolution. Marine researchers normally begin with the assumption that unusual formations encountered underwater are natural unless overwhelming evidence demonstrates otherwise. The evidentiary standard for proposing any alternative interpretation is extremely high. That assumption is reasonable. A marine geologist could hardly complete a normal survey season if every strange ridge rock or seabed return were treated as evidence of something extraordinary. But that same working assumption has another consequence. It can quietly eliminate an entire category of possible discovery before any particular object receives closer examination. If the corpse of technology interpretation of the Baltic anomaly were correct, then finding a single unexplained object in the Gulf of Bothnia would not be the most important issue. The more unsettling implication would be how many others might exist elsewhere. There are enormous stretches of ocean floor that have never been examined at sufficiently high resolution. There may already be strange formations that were mapped once labeled unusual geology, placed into a database, and never investigated again. Under this speculative interpretation, the image that emerges is therefore much larger than one artifact resting beneath the Baltic. The ocean floor would no longer represent only the graveyard of vessel sediment and geological formations described within the normal framework. In locations humanity has not examined carefully enough, it might also contain the remains of technologies and perhaps civilizations for which the existing framework has no classification. A survey ship might cross above an unusual rocky outcrop, recorded as ordinary geology, and continue onward without anyone realizing that the vessel had just passed directly over the remains of something its crew had never been trained to recognize. None of this means the Baltic Sea Anomaly has delivered an intact spacecraft. It has not produced one perfect piece of evidence capable of closing the case with a simple headline. Instead, 14 years of debate and investigation have left behind a more ambiguous possibility. Evidence of something far stranger than the conventional picture of humanity's past might have been resting on the seabed all along, concealed beneath the appearance of geology entered into records as rock and forgotten by survey teams that had no obvious reason to examine it twice. The samples remain stored at Stockholm University. The anomaly remains on the bottom of the Gulf of Bothnia. The 300-meter trench still runs behind it in a straight line, and according to every published account of the phenomenon, the dead zone continues to interfere with electronic systems that cross into its boundary. What has never taken place is the kind of comprehensive, heavily funded follow-up expedition that could potentially settle the argument in one direction or the other. That is where the most unsettling part of the story remains, not simply in the existence of one object, but in the number that might exist. No one knows how many more structures like it could be scattered across the black floors of oceans humanity has only begun to map. They could be sitting there silently concealed beneath the appearance of stone, preserving the structural memory of something we still do not know how to identify. What do you think the Baltic Sea Anomaly really is? A rare geological formation, the remains of lost technology, or something else entirely? Share your interpretation in the comments and subscribe to the channel for more investigations into mysteries still waiting beneath the surface.